సో అభిరామ్ ఏంటంటే రియల్ టైంలో మనము ఎక్కువ రికార్డ్స్ హ్యాండిల్ చేస్తాం కాబట్టి అప్పుడు ఏంటంటే మనకి పాండా స్లో ఉంటుంది, చాలా స్లో ఉంటుంది. సో పైస్పార్క్ అనేది మనం లోకల్లో యూజ్ చేయం కదా, పైస్పార్క్ అనేది మనం అజూర్లో యూజ్ చేస్తాము. సో అక్కడ ఏంటంటే మన కంప్లీట్ ఎన్విరాన్మెంట్ లైక్ ఇప్పుడు మనకి ఉండాల్సిన ర్యామ్, స్టోరేజ్ ఇవన్నీ ఎక్కువ ఉంటుంది స్టోరేజ్. సో ఎవ్రీథింగ్ ద స్టోరేజ్ అండ్ స్పీడ్ everything will be like huge amount of storages and everything. So ఇంకోటి ఏంటంటే like parallel processing, like distributed computing. So if we have one task, it will be distributed to multiple processors in cloud, that is like in this Azure. So that's why it will be very fast. Yeah. So today we will discuss about this ELT process. Previously we have seen ETL, extract, transform and load. What we have done in that, we'll extract the data from different sources like CSV files, JSON files, and we'll perform some transformations, like we'll perform aggregations and joins. So different types of operations we used to perform, and we can save back the data to the data frame, or else we can save the data into SQL database or data lake, data warehouses. These are the topics from like Azure data storages. So we can either save the data in databases or data warehouses, data lakes. That is in ETL process. So here in ELT, extract, load and transform. So here what we'll like, this is a process for extracting the data from different sources, like the sources might be databases or whatever it may be, and we'll take the data from we'll take the data and store the data into a data frame. Means that is called loading. We'll load the data from some different sources and to a data frame, and we'll perform the transformations on the data frame. Okay, extract data from source, load the data into a data frame, perform transformations on the data frame. So how we are extracting? So we will extract the data from like RDBMS, cloud storages, Azure data like files, JSON, CSV, different files. So any of the sources can be compatible for extracting the data. And loading, we'll load the data into a Spark data frame. And transform. So here, once we save, like we load the data into a data frame, we can perform different operations. We have seen, right? Filtering, joins, aggregations, data type casting, user different functions and SQL queries. So till we have seen till user different functions. So one more thing here is, once we get the data into a data frame, we can create a temporary view. So if you have idea on view, what is a view? View is a temporary table in SQL, right? Temporary. So it is a temporary table in SQL. Similar to that, we can create a view in PySpark using the data frame. So why we need to create that temporary view, we'll discuss in next. So here what, transform the data, just we are performing these operations. Understood, right? ELT, extract the data from sources, load the data into a data frame, perform different operations called transformations, like filtering, joins, everything. This is called ELT process. So compared to ETL, this will be very fast. This process will be very fast because performing operations on the data frame will be one part, and the other part is SQL queries. We can write the SQL queries on the temporary view created from the data frame. How to do that, I will explain you. So this is a theory part. We'll start the coding. So I have created a ELT Jupyter notebook. So first thing is, we have to start the Spark session. how to start the Spark session? We have to import the PySpark.SQL, right? PySpark.SQL. Spark session. So we have to import the Spark session and we'll see different operations. PySpark.SQL.types. Import. So here I'll import structure type. I'll explain you what is this. So we'll import structure type, struct field, string type, integer type. So these are the functions or keys we'll import. And next, what is the first step? First step is to create the Spark session, right? So create Spark session. So how to create Spark session? I'll create a variable Spark session dot builder dot app name. So here we can give. So we are performing ELT using PySpark. This can be anything, just a sample name. What is the method name we use? Get or create. Get or create is a method name for. So using this, we will create the PySpark session. So next step. So we'll define the data. Define the data. So here. Employees data. Good. So I'll just create a list of the records. Just a minute. So first I'll create a list of employees data. So this employee one. So what is this called? Can anyone come up? This square brackets is list. So list of employees data. What is this individual record known as in Python? Can anyone say? This individual record, what we'll call this? Seems like no one remembered that. This is called as tuple. Tuple. Small parenthesis means tuple. Square brackets means list, right? So I'll create 5 employees details. So this is the employee data. So here what we'll call this as, here this step is known as extracting the data. So instead of this here I have given static data. We can read it from CSV files or any files we can read it, right? So this is called as extracting the data. Extract the data step. This employees data. I'll create one more one. Department data. So again we'll be having tuples. HR. So we have employees data and department data. Both are a list of tuples. These are not the data frames. So here we have to define the schema. So normally you have in SQL, right, a schema. We can, before creating the table, we can define the schemas. So why we'll define the schemas? If we define the schemas, the further operations will be very fast. So the creation of a data frame from this data will be very fast. So here you may feel like this is very less amount of data, but in real time we'll be having 1 lakh records like this. So to process that 1 lakh records into the data frame, if we define the schema for that data frame, that process will be very fast. So that is the reason we'll define the schema. It is not mandatory, but this will improve the performance. Define the schemas. So I'll define first employee schema. So how to define? We'll use struct. So struct means this can store any type of the data. It may be integer, it may be string, any type. So here, what are the fields we have? I have employee ID, comma, string type, true. So here if you see the struct, we have to, okay, we'll define the fields. Struct field. So here employee ID, we'll give name, we'll have the same. So employee ID, name, third one is department, fourth one will be salary. So this is the structure created, I mean schema for this employees data. We have total four fields. So four schemas like employee ID, name, department and salary. Now we need to create one more schema, that is for department. departments we have 2 records, right? Only 2 columns. The first one will be department. Second one will be location. Okay. So here we have created that, we have extracted the data, and we have defined the schemas for both the data, including employees and department. Next. Give me a minute. So next step is load the data into the data frame. Load data into the data frame. So how to load the data? Spark, what is the syntax? We have gone through, right? Employee data frame equals to Spark dot create data frame. We have seen already this one. Create data frame. And what we have to pass here? You remember? Data equals data to employees data, and we have to pass the schema here. Employee schema. So this okay. Employee schema. So we have passed employees data. So this is our employees data. And one more is department data frame. Department underscore df spark dot create data frame. So here data equals to department data. Schema equals to department schema. So like this, we have passed our list of employees data and departments data and respective schema. Okay, this is our loading the data into the data frame step.
Sure, for the salary it will be integer type schema.
What happened?
For salary, it will be of integer type while defining.
Okay. Yes, correct. Integer type. Yeah, correct. So this true is for it can be null or not null. In SQL also we will be having, right, null or not null, that parameter. So this true is for that null, or to define this null or not null. So now we'll see that so we have created the two data frames, employee data frame and department data frame. So this is important. Remember this. How to define the schema? So using struct type. So from where you got this struct type? From PySpark.SQL.types. We have imported struct type and struct field also. And whatever the type we are having, string type and integer type, all these 4 we have imported them from PySpark.SQL.types. Okay. Using that schemas we have defined. Now, so we have extracted the data and we have completed the loading the data frame. So EL is completed. Next, what is our next step? Transforming the data. performing the transformations. So, transformations. So first transformation, I want to join the employees table with the department table. So how to perform? So result equals to spark dot. So okay. So this kind of transformations we have already seen. Now what I'll do, like I'll create a temporary view from this data frames. So I discussed, right? I'll create the temporary views. So via temporary views also we can perform. Using PySpark operations we have seen in previous classes. So today we'll skip this and we'll check directly SQL queries, how to write SQL queries. So before this transformation, I'll create the views then first. How to create the views? Create, or we can say them as a register temporary views. So how to create a view? emp underscore DataFrame dot. This is very important. Create or replace temp view. This is a method name to create a temporary view using the data frame. So here we have to give the name for the view. I'll give employees. Okay. Now our temporary view name is employees. From employee data frame, we have created a view called employees. And similarly, I'll create or replace temp view departments. So now here we have created them. Okay. After creating them, so what we have to perform, so here we have created temporary views, and now I want to perform transformations. So how to perform the transformations? So my first transformation I want is join the employees with the departments. So I'll store it in result underscore 1 spark dot SQL. So here we'll open parenthesis, we'll close this in this. So here I'll keep a colon. Okay. 1, 2, 3, close the parenthesis. So in between this spark.sql 3 double quotes, here we can write the SQL queries now. So for so on data frame, employee data frame, department data frame, we cannot directly perform SQL operations, right? So that we have created a views. On these views, we can perform any SQL operation by using this syntax, spark.sql. In this between, we can perform our SQL operations. So here, I want to join my employees table, like it is a temporary view, employee temporary view with departments view. How to join that? Select e.emp underscore id, comma e dot name. So e dot department. So I want everything as an output, like so till here from them. Okay, I'll show you first. From where? From employees. So for employees, I have given E, join departments D, alias name is D, here employees E. So how to perform join operation using on and the common, like here we do. So what is the common column here in both the here data frames? Department common thing. So employee is E, right? Alias name E dot department equals to D dot department. So using this common column, that is foreign key, we are performing join operation, and from the employees E, whatever we are selecting, employee ID, name, department. These three we are selecting from employees table, and from departments table, what we have, department location. Right? So I will d dot location, and I also want salary. At last I want to display salary. So here what we are doing, we are joining our employees with the departments. Join employees with department, so that we can get which employees from which department and which location, like indirectly which location. Anyhow, Alice is working in HR department. From here we can say, but for which location means we cannot say by looking it in this single table, so that we can perform join and we can define that. So now I want to display result underscore 1 dot show. So here if you see, we got the output, like we have done the join operation of employees with the department. Understood, right? So in between this, we can perform any of the transformations, means any of the SQL query can be performed. Even without creating these views also, we can perform on the data frame directly. But if we perform like this, this will be very fast, because directly we are updating the views. Affecting the views will be easy compared to the data frames. Okay, so this is a join. Like we'll see few more examples. No? Next we'll perform filtering. So what I want to filter, like we'll filter employees with some specific salary. So salary is 5,000. Okay, least is zero. We'll filter salary with like greater than 4,000. So how to perform filter? So this is just a condition. Salary greater than 4,000. This is small condition, right? How to perform this in SQL? Result to Spark dot. This is mandatory. Spark dot SQL parenthesis 1 2 3 close. This is mandatory. This is syntax. So here we have to perform the SQL query. Select name, comma salary. So from employees. So we will split where how to write the condition, just directly salary.
Where salary is greater than
4,000. That's
4,000.
4,000. So here 4,000. Yeah, we can write it. So this is equal, right? We can write in a single line also. Multiple and single line is fine. Anything is fine. So we'll see the result underscore 2 dot show. So greater than 4,000, we have 2 employees, David and Eva. You know SQL, right? Select is a statement used for getting the records, like that specific columns from table name, where we have to, if we want to perform some conditions, we will write where keyword. Filtering. Now we have seen joining, filtering. We'll see now aggregations. For data frame, we have seen aggregations, right? So in SQL also we'll see aggregations. So what I want is, I want average salary for each department. Okay, for this department, how much is the average salary? For HR department, how much average salary? Like that I want per department. Average salary per department. So how to find it? Result underscore 3 equals to Spark dot SQL. So here, how to get average salary per department?
Select department.
Yeah, select department.
Average
of
bracket salary
salary.
alias.
So we can give alias name anything. Average salary I'll give. From employees.
From
Employees. What is the final? This last line is the main thing. For
group
this.
by
Hmm.
group by
Group by
department.
department. Yes. So in interviews, this is they will ask these kind of questions majorly. So we have to remember this group by department. This is the main logic in this complete query. Result underscore 3 dot show. So here we have got the average salary. The aggregations. Okay. So now we'll perform like count. Abram, can you give query like I need employees in each department. So count of employees in each department. How to write that? I need the SQL query.
Yes.
Can you give the query? How to get this count of? So this is the tables. I need the count of employees
Each
in
department.
So
Okay.
here IT are 2 employees, HR are 2 employees.
Yes.
So like that, I need the count. How to perform that?
Yes.
Query.
Select
Select.
department,
Okay.
comma, count, department as
Count is space,
braces, sir.
braces. Okay.
Department. So, yes. From employee, close the braces, sir.
Okay.
From employees, group by department. Yes.
Okay, we'll check. Result underscore 4 dot show. Is this correct?
Yes, sir. Here we didn't take any alias, so
That's fine. That's fine.
Yes.
We can. That's why we got this direct message. Okay. So we can list as employee count. So employee count is HR2, IT2, Finance 1.
Yes, sir.
Okay. So yeah. So Abhiram, like just one more thing. Like I want order of employees
Okay.
by salary in descending order.
Okay.
Yeah. Can you give me? I'll create result 5 equals to spark.sql